I'm okay with that. All right, we are magnitude of the equilibrium constant. So we learned about the equilibrium constant yesterday. That was our K value. All right. If we have a K value that is smaller than 1, usually 0.001 or smaller, and typically they'll write that in scientific notation, so it'd be 1 times 10 to the minus 3 for this guy. That reaction is going to barely proceed. You're not going to end up with hardly anything on your product side. Okay. If your reactant is, less or greater than this, but less than 1, then typically your reactants are favored. You're going to have more of these, a higher concentration of these versus these guys. And then obviously the opposite is true. So 1 times 10 to the 3 or less is typically going to be products favored, and then it's going to, anything greater than 1,000, which is 1 times 10 to the 3, it's going to essentially be considered that it goes to completion. There's very little left of the reactants. Okay. So down here, given the following reaction, what can be said about the relative amounts of the reactants and the products when you reach equilibrium? So you're just basing your information by looking at this value. Well, this value is very large, so reaction will go to completion, and there will be very few of this material left after you are done. All right, good. All right, we do. You are given this reaction. This is your K value. So what does this indicate? This 10 to the negative 4 indicate? Well, if we go back up to our chart here, it's going to say that we're barely creating any of this material at all. Okay. If 1 mole of A and 1 mole of B were placed in a 1 liter container, that means that we have 1 molar this and 1 molar that, and allowed to come to equilibrium, what would be true of the partial pressures of the gases at equilibrium? Okay. If we have 2A plus B, that means that we're going to use up 2 of A for every B. We also know that we're going to have a much larger amount of this stuff than this stuff created because our K value is very small. Does that make sense? All right. Oops, I thought I had the eraser on. There we go. That is not an eraser. That says eraser, but it's not erasing anything, you guys. It's just making a hot mess. There we go. Now we can see what's going on. So which one of these are we going to have the most of in that container once it reaches equilibrium? But some of A is getting used up, and it's getting used up twice as much as B. So you're going to have more B than you will have A, and you're going to have very little C made because that is small. So let's try to find a way here where we're going to have very little C. We're going to have more B than A and more B than C. So C would be our answer here. A is not going to be equal to B. It can't be equal to B because A is going to get used up faster than B. A is less than B. but C would be less than B, so it can't be this one. This one, that first part, that is the right answer. And then here you would have less A than B, and here they're not equal, so it has to be C. Yay or nay? Complete total logic problem. Yes? Applying what you know about stoichiometry and now what you know about K, and then the rest of it's just logic. If you can do logic problems, you've got about a quarter of AP Chem licked. All right, 7-6. 7-6 is dealing with the properties of that equilibrium constant. So properties of K. So you can find K or Q. We talked about how to do that yesterday with the equations. Okay, equations look like this. And we can do that for a multi-step reaction, kind of like Hess's law, which some of you are still slogging away at that lab from last unit. I need that eventually. Okay. If we have this as our equation, and I think Derek was asking me about this yesterday, about if we had this as our equation and then we flipped it around, what would we do? Okay. It would essentially be, that one was a 1/, because there wasn't anything in the reactant side. But here, all you're going to do is take the inverse of it. So the inverse of whatever that K value is the reverse reaction. Does that make sense? And you all should have on your fancy calculators an inverse symbol on there to be able to click. If you don't know where that is, come and see me and I'll try to find it for you. That's assuming you've got your fancy graphing calculator like I told you to get. Okay. If you multiply the reaction by a factor, then you're going to square that K value. So if you had to go through, because of Hess's law, and multiply by that to be able to get things to equal out. Remember how we had to flip things around and multiply by things to get stuff to cancel out? If you have to do that, then whatever factor you're multiplying it by, you're going to take that and raise it to that exponent. Okay. If you have to combine reactions to get the overall K, you multiply their K values. Is your head hurting yet? Yeah. Let me see if I can make it hurt a little more. All right. So we have our overall reaction down here, yes? Okay. We got to figure out how to manipulate these in order to get that reaction. Okay. So I need, sorry, excuse me. I need to get, I've got my E on the right side. I've got, okay, so everything's on the right side at least. That's good. But I need to get, this D doesn't show up in the final reaction down here. So D is called what? It shows up here. It's gone here. What do we call that? Intermediate. Good. Okay. I need to get rid of that D. So what do I need to do to this equation to get rid of that D value? Double it. I need to double it. Yep. Okay. So I'm going to take this and I'm going to double it. And when I double it, what do I have to do to the K value? No, I have to square it. Yes, not double it, square it. Remember up here, if you have to multiply the reaction, then you have to raise that K value to however much you multiplied it by. So here we multiplied by 2. We've got to square that value. Okay. So when I do that, then I end up taking, try to find my voice here. Sorry, guys. C plus 2D. This is going to be 2D plus 2B. And that's going to give me 2E. All right. My D's are going to cancel. My B's are going to add to one another. So that's how I get the 3 here. I've got my A, my C, and my 2E. All right. So now we need to take these and do what with them? Multiply them. Yep. So I'm going to take 5 times 15 squared, and that's going to give me my K value here. And when I do that, that's 1125. So once this thing reaches equilibrium, am I going to have more of this stuff or more of this stuff? Yes, I'm going to have more product because this value is greater than 1. Yep.
You multiply the K values because you combined the first two equations, right?
Yes, correct. Yes. So I multiplied these two together because I had to combine these two equations to get the overall. So I multiply those together. I square this first and then multiply them together to get this value. And then this value tells me that this reaction is going to go almost to completion. And we learned that back over, come on, Libby, get the right page here. Reaction goes to completion. If it's greater than 1,000, then we consider that the reaction's gone to completion. So we're kind of combining the ideas from both of these together to get this information. What's wrong? You good?
Yes.
Okay. All right. We do. All right. Let's see. So this is our overall reaction. We have our kind of steps here that we can go through to get it. I've got this guy on one side. I've got my OHs here, which means I need to flip this guy around because I've got to get OH on the other side. So I'm going to have to flip him around. I'm going to keep him as he is. So I'm going to go ahead and write him down because that's going to get me that guy. Cl HX minus plus Cl minus. And that is 6.2 times 10 to the 9. So I've got him. He's on the correct side. This one I need to flip around, though, because I've got to get OH on the other side. So I'm going to flip him around. So I'm going to put OH plus H. And that's going to give me H2O. And if I flip that around, what do I have to do to the value for that? Inverse. So 1 over 1 times 10 to the minus 14. All right, I got him on the correct side. Now I need to, I don't have any HX's showing up here. So I need to get rid of that HX on this side. So I need to flip this guy around. That will also pull out by flipping that around. That's also going to pull this H out, which I need to get rid of. And it's going to get this guy on the correct side. So I'm going to flip this equation around as well. So I'm going to get hx minus, over here I'm going to have x plus h plus, and again, if I do that, I've got to inverse that k value. So 1 over 5.8 times 10 to the minus 4. And just to double check, I just want to go through here and make sure that I've got everything canceled out. I've got that guy gone. My h plus is gone. Is that it? It's going to give me this guy on this side. It's going to give me my OH over there. It's going to give me my X, my Cl, and my water. Okay, so yep, I've got everything canceled out that I needed to. I've got my final equation satisfied. Now what do? I'm going to multiply all of these values together. I didn't need to multiply any of these by anything, so I don't have to square or cube or anything to get that to work. I just need to multiply all of these things together, which I got a little excited about and tried to put it in the wrong spot. Sorry. All right, so I'm just going to multiply all of these things together. And when I do that, I get 1.10 times 10 to the 27th. What's my unit? Nothing. K's don't get units. All right. What does this say? Which was going to be favored, my products or my reactants? Products. Very much so. All right. There you go, my dears. Have fun flipping some equations around. I gave you a few minutes to work on that. I probably have a couple of those. I might pull out a few of those